Hello students, welcome back. In this question, we are supposed to choose a correct statement or statements from the given options. The first property given here is basic strength. The given compounds are tertiary amines because the nitrogen is attached to 3 carbons. The first structure is a Quinuclidine kind of structure, a bicyclo compound where nitrogen is a part of a ring, and it acts as base because of the lone pair present on the nitrogen. Similarly, the triethylamine also acts as a base due to the lone pair of electron present on the nitrogen. But the quinoclidine-like structure is more basic as compared to the triethylamine. Why is it so? When nitrogen is part of the ring, because of this rigid structure, the groups are being pulled back like this because they are all connected to the same carbon like this. So what happens to the lone pair? The lone pair is free for the incoming proton. It is given easily to the proton. In case of triethylamine, this is not happening. Because of the free moving ethyl groups, the lone pair is somewhat hidden for the proton. So what happens to the attack of proton? That will not happen that easily. Therefore, this is a correct statement. The second statement is about the acidic strength of 1-nephthol and 2-nephthol. In fact, this is a correct statement. Why? What is the reason? Just the position of the hydroxyl group on naphthalene, will it make difference in the acidity? Definitely it does. And you will be shocked to know the reason behind this, because the groups are same here and both will undergo resonance. Then what might be the reason? So let's discuss that in detail as it is important. When nephthol gives the acidic proton, it forms a conjugate base. And how this conjugate base is stabilized, as I told, by the resonance. Let's write down few resonating structures for both 1-nephthol and 2-nephthol. Then you will understand the reason. How to write the resonating structures? The movement of electrons takes place like this: atom to bond, bond to atom. So here we have the negative charge. Again, it will undergo resonance like this, and then you can write the next structure. You have to practice these structures on your own. Only then you will understand how to write resonating structure for any given molecule. Now, from this ring, it's moving on to the next benzene ring what we have here, right? So how does that happen? Look at this. Here, from atom to bond, bond to atom. What about the oxygen? It will be still having double bond, and here the new bond is formed, and here we have the negative charge. And then what happens? It will undergo further resonance. It goes on. Let's see for 2-nephthol molecule what happens. Similarly, we have to write the resonating structures. How do you write the resonating structure for 2-nephthol? This is a conjugate base formed from the 2-nephthol molecule. The resonating structures are quite different here. You see, when the electron moves here, this is the double bond which will move to this position. So how will be the next structure, resonating structure? Observe carefully, I am using double-headed arrows here indicating they are all resonating structures. So now what happens? The negative charges here. Then when the electron moves here, these electrons will move here. The bonding electrons will move like this. Now the question is, how many resonating structures do you have to write? No, this is enough to predict the stability of the molecules. How so? Just observe the first few structures. Both the rings here are aromatic, that means they are obeying Huckel's rule. Here also same. In this case also one aromatic, right, obeying Huckel's rule. Here also same. But in this case, this ring is still aromatic in nature, but here it is losing that Huckel's 4n plus 2 rule. That means what? When we are writing resonating structures, we are getting two structures wherein the benzene ring here is retaining its aromaticity. But for 2-nephthol molecule, there is only one resonating structure which is retaining the aromaticity. This is the only difference. You don't have to write all these resonating structures in the exam, but you have to remember that 1-nephthol is more acidic than 2-nephthol due to the resonating structures. Now let's move on to the third statement. We need to compare the stability of the given carbanions. The first carbanion is part of the aromatic ring. That means what? This is stabilized by resonance and also it is part of Huckel's 4n+2 rule of the aromaticity. Because of this, the carbanion here is more stable as compared to the anion present on the sp-hybridized carbon. Although this carbon is sp-hybridized, more electronegative, hence it stabilizes it. That is absolutely correct. But the carbanion here is undergoing resonance and it's part of the aromaticity. That means it is more stable as compared to this. Here, this is a wrong statement. So, C is not correct. If you want to learn more about the aromaticity, I am giving you the link in the description. You can please click the link and watch the video to learn more about the aromaticity. To compare the basic strength of the given amines, check for the structures of the molecules. Here we have two methyl groups at the ortho position. Now, will it make difference? Yes, it does. How so? Usually, the aromatic amines are less basic because the lone pair of electrons present on the nitrogen will be in resonance with the benzene ring. That means what? It is less available for the incoming proton. But in case of the second molecule, what happens is due to the ortho effect here, that means there is a steric hindrance here, it makes this nitrogen to go perpendicular to the positions of the methyl groups. That means what? These two methyl groups go away from the plane of these two methyl groups. Because of this, what happens? The lone pair cannot be in resonance with the benzene ring. That means if it is not in resonance, that is available for the incoming proton. Hence, this is more basic than the simple N-N dimethyl aniline molecule. Therefore, this is also a correct statement. This is how you have to solve the question using the basic concepts of organic chemistry. If you still have any questions, please do comment your queries in the comment section. I will help you with that. And don't forget to solve the question given at the end of the video. All the best.